Hi, this is Lisa Knight, and I am going to take this time to give you some feedback on your Module 3 assignments. First of all, let me apologize for being late to getting back to you with grading and also following up on your discussion board. I had a very bad stomach flu the beginning of this week, but I'm back on track now. First thing I'm going to do is I'm going to talk about your homework. And after looking at problem one, some of you need a little refresher on how to find components and how to find magnitude and direction. So this is something that doesn't go away. You have to know how to find the x and y components of a vector. And if I give you the x and y components, you have to be able to find the magnitude and the direction of the vector. So to find the x and y components, you're going to use sine and cosine. X is going to be equal to the hypotenuse times the cosine of the angle, and y is going to be equal to the hypotenuse times the sine of the angle. The angle needs to be in degrees, so make sure your calculators are in degree mode and not radians. So if you're given a vector, like in problem 5, of 200 meters per second at 30 degrees, the x component of that vector would be 200 times the cosine of 30, which is 173 meters per second, and the y component would be 200 times sine of 30, which would be 100 meters per second. If you plug in the polar angle for cosine and sine, then you will always get the right sign. So remember, this vector is pointing up in the first quadrant, so x and y should be positive. But if it was pointing down in a different quadrant, then if you use the polar angle to find the cosine and the sine, then you'll get the right, like negative for west or negative for south if needed. When you want to find the magnitude, you're just going to use Pythagorean theorem because the x and y components are given to you. That means they're at right angles to each other. So if you walk 10 kilometers west and then you turn and you walk 5 kilometers south, the total displacement would be from where you started to where you ended, indicated by this vector called r, the resultant, which happens to be the hypotenuse of this triangle. So if we use Pythagorean theorem, r squared equals x squared plus y squared. So x and y are your components. So r squared is equal to 5 squared plus 10 squared, or 25 plus 100. So r squared is 125, and if I take the square root of that, then my magnitude would be 11 kilometers. The direction is going to be found using tan because you have the opposite side of the angle and the adjacent side, and tan is opposite over adjacent. So that would be tan theta equals 5 over 10, or 0.5. Then you take the inverse tan of that decimal. It gives you an angle of 26.6 degrees. So how do I know if that's the polar heading? Remember that polar headings are always measured relative to the east axis. So if I want to find the angle that's a 30-degree angle and I want to give the polar direction, I have to start at the 0 degrees and go to 30 degrees. That's always in the first quadrant. So here's the rule of thumb. You have to adjust your tan angle that you find for the quadrant you're in. So if you're in quadrant 1, and that means the x and the y are both positive, then you don't have to do anything. Whatever the angle is, that's the polar heading. So if in this case, you had a positive x and a positive y, and the angle came out to be 26.6 degrees, then the heading would be 26.6 degrees. But if you had a negative x and a positive y, you're in the second quadrant. So what you want to do is you want to subtract that angle off of 180. So instead of it being 26.6 degrees, it would be whatever 180 minus 26 degrees is. In other words, it would be, if you start from 0 and go all the way around, it would be everything minus whatever that angle is. In quad 3, if your x component is negative and your y component is negative, you're in quad 3. And in order to find that polar heading, you would just add 180 to the angle that you find with tan. And when you're in the fourth quadrant, you have a positive x and a negative y. And that means that you subtract the angle that you find off of 360. So in your homework, excuse me, in your homework, you had a couple of Examples like in D was in the fourth quadrant, so you should have taken that angle and subtracted it off of 360 and gotten to 97. And in E, that angle was in the third quadrant, and you should have added it to one. It was in the second quadrant, and so you should have taken it off of 180. So some of you guys are a little confused about finding polar headings, so make sure that you review that. Excuse me. In problem 2, you had airplane trying to go north, but there was a westward wind. So think, if I'm trying to go north and I have a wind pushing me to the west, I'm going to end up in this direction. If you find that angle, it turns out to be 8.5 degrees west of north. But if I want to go north, then I would have to head in the other direction, right? Instead of being pushed off to the west, I would need to head towards the east. Excuse me. Really sorry. Really sorry for coughing in your ear. I would have to head in this direction, somewhere north of east. So it would have to be 8.5 degrees east of north. In problem 5, let's review a projectile tossed up at an angle. When I throw a projectile up at some initial velocity v0, I'm giving it a forward and an upward speed. My forward speed is my x component, and my upward speed is my y component. These are happening at the exact same time, but they're independent of each other. The only thing that can change them is a force that's acting on them. Since we're ignoring air resistance, there is no force acting in the x direction. So the x component will always stay the same no matter where you are, whether you're at the beginning of the path, the top of the path, or just before it lands. The y component, however, is being tugged on by gravity, and it's going to slow down every second by 9.8 meters per second. So after 1 second, it's going to be shorter. After another second, it's going to be another 9.8 meters per second shorter until you get to the top where the Vy is actually 0 and it stops rising or falling. And then the next instant, it will have increased its speed in the down direction. The good thing about this is that it increases its speed by the same amount that it decreases on the way up. So as it falls down, it's going to pick up speed at the same rate every instant. So when you get to the exact same point that it was launched at, it will have a speed that's exactly the same in the y direction, but it'll be negative because it's going down. So projectiles are really, really symmetric when we don't have to worry about air drag. So Vx in this case was 173 and Vy was 100. So to start with, Vx is 173 and Vy is 100. But at the top, Vx is still 173 and Vy is now 0. And just before landing, Vx is still 173 and Vy is now exactly the same but in the opposite direction, negative 100 meters per second. Once again, sorry. Acceleration, therefore, it's only in the y direction because Vx is always staying the same. So Ax is 0, and the acceleration in the y direction is that of gravity, negative 9.8 meters per second squared. When it comes to finding the height, you're going to use a kinemax equation, and because the kinemax equations are for things that are accelerating, you need to use the velocities that are accelerating. The velocities that are accelerating are the Vy's. So to find the height, you want to look at just the first half of the trip, right? You want to start where you start and end at the top of the trajectory. So your initial Vy is 100, but your final at the top is 0. Gravity is negative 9.8, and you're looking for the height. So you want a formula that has distance in it, that has initial velocity and final velocity and gravity. It doesn't have anything to do with time at all. So that would be this one right here. If I want to find the height, I would use final velocity squared equals initial velocity squared all over 2 times the gravity, and I would solve for delta y. And when you do that, you'll get a distance of 510 meters. By the way, this is exactly how you solve for A. In that case, you're just throwing it straight up at 100 meters per second. In solving for the time, you know that now you're talking about the whole trip. So you throw it up at 100 meters per second, but it lands at negative 100 meters per second. So you're going to use a formula that has the final speed, the initial speed, gravity, and time in it, in this case. And if you do that, it'll be this formula, Vf equals Vi plus At. And when you solve for time, you should get 20.4 seconds. This is also how you solved part B in number 4. The biggest problem people had, though, is they only solved for half the time. They used a final velocity of 0. It's got 0 velocity in the y direction when you're at the top. So when you found 10.2 seconds, that was the time for just half the trip, not the time for the whole trip. And then when you want to find the range, what's nice about the range is that's how far away you are on the x-axis, how far out it lands. Well, it's not accelerating. So Vx is just distance over time or range over time. And once you know what the time in the air is, 20.4 seconds, and you know what Vx is because it never changes, 173, then you multiply those and you get like 3,500 meters. This is a classic problem, and you should be able to solve something like this. All right, let's talk a little bit about your lab. So I posted a video that gave you some specific instructions because it's become to my attention that you guys can find the answers to those Vernier Physics with Video Analysis labs. And a lot of you guys are finding them and paraphrasing them. Or maybe just outright copying them. So instead of just giving you a 0, I decided that I would put a little twist to the lab in the video instructions. So please make sure you watch the video instructions and you know exactly what I'm asking you to do. And in this particular case, I wanted you to calculate the velocity in the x direction and in the y direction at each instant. And I showed you how to do that. I did a couple of examples for you. And then I asked you on your diagram to label those values. This way, you would then be able to use that to determine if you were traveling at a constant speed or getting faster and faster. And in fact, in this particular example, you see that you're always traveling at 1.5 meters per second forward, but as you begin to fall, you go from 0.3 meters per second in the negative direction to 4.18 meters per second in a negative direction. So you're increasing your speed every instant. So I took off 10 points if you did not do that at all. Next time, I will take off more points for not following the instructions in the video. And let me just comment that those instructions will be posted at the beginning of the second week. I will always post those videos, instructions at the beginning of the second week because during the second week, that's when I want you to concentrate on your lab. During the first week, I want you to concentrate on reading and watching the videos and looking at your homework so that you can start the process of trying to get help on your homework. And to help facilitate that, that's what the discussion is there for. So the way I graded your discussion is you got 50 points for posting that initial post by its due date. And I was really lenient on the quality of the post, but you guys did a great job this time with that. Y'all did much better job. I need you to post to 2 classmates on 2 different days. I don't want you waiting to the due date to post to 2 people because that's not going to help anybody if you wait to the last minute. The idea is for you to stay interactive in the class and stay on top of things. That's what the purpose of the discussion is. So I took off 25 points if you did not, if you posted to everybody, okay, and you posted to at least two classmates, but you did it all on the same day, you did not get both 25 points. One of your 25 points were taken away from you. Physics Form 4 will also be graded on the quality of the interaction. So most of you guys did, there were some of you that did an outstanding job trying to help each other out, and I really appreciate that. I'll give extra credit next time for that. But many of you did a great job, but some of you did not. You were just saying, oh, yeah, it's hard for me too. Okay, that's not helping anybody. We all know it's hard. It's hard for everybody. What we want to do is try to help each other. So, the way it'll work is you'll make your first initial post as indicated by the due date. And as always, I will go through that next day and I will make suggestions of further readings or an example or something to help get you started. And then the next week, you guys will choose two classmates to give some constructive feedback to. And what I mean by constructive feedback is I want you to look at the problem that they have posted, and I want you to give them either an additional website, or maybe you can show them how to do it, or you can give them pointers. This time the homework is in WebAssign, so you'll get some automatic grading, but it's going to be really important for you guys to not just Google an answer and not understand it, right? Googling answers is great if you use it constructively to help you learn from it. But if all you're doing is just trying to get a homework grade in this class, that doesn't help at all, because you got to learn how to do the problems. So, I know there are a couple of you that really need help. If you go to the ACE at Brunswick, you can get a tutor. You can either get it through Spark Thinking or you can get the tutor that they have available for you. And it's for free, so do that. If you don't want to do that, if you're a distant student in the true meeting, then maybe your home college will have tutoring available to you, or you can always get up with me online. So please, please contact me. If I don't see your email within 48 hours, something's wrong. So send me a text as described in the syllabus. And I usually answer texts quicker. Just make sure you tell me who you are and what class you're in. I really do want you guys to be successful, and I don't want you to struggle more than necessary. But it is, the physics is hard, and it doesn't get any easier. So as you see, it builds on itself. So please, please, please contact me if you need help. And hopefully I won't have the flu again and be late on looking at emails. Talk to you later.